Hello. From the last video, I already covered the SIG action. The purpose of this API is to handle the SQL. This is like the SQL API, but I already covered. This is an example with respect to SIG action. This example has to be handled. Many APIs has been used. The starting SIG empty set. This one will initialize our flag values to 0. Next SIG add set, it will add the flag value as 1 with respect to signal mask. In this case, we are taking the terminal signal. For this signal, we are setting the flag value is 1, and we are accessing the same signal and adding to the signal mask by using SIG process mask. So as we know that SIG set mask is nothing but the existing signal mask value will be overwriting with the new values. The new value is nothing but in this case terminal signal. If this statement is failing, I mean if statement is failing, the P error statement is executed. Otherwise, SIG empty set this statement is executed. Here, action.sn mask is nothing but there is a one structure with respect to SIG action. What we are using, there is a action. So in that case, you wanted to send the additional signals as part of the signal mask. In that case, I need to use the action.sn mask. So as I am using segmentation of signal, we are adding to the signal mask. That is SIG add set. And for this signal, there is the enter as a different one. Okay. As we know, there is a different methods that we use for handling the signal. One is the default action, and the signal. Third one is calling the user different function. So this program, as we are using the user different function. Next section of SIG value. So usually there is a child signal is generated. In this case, this value will be different. Otherwise, this value will be 0. Then finally, as I am calling the SIG action, that is nothing but whenever the input signal is occur, then what is the action to be taken? It is pointing to for me function. As we know that it is a different function. So in this way, just we need to handle the SIG action API for handling the signals. Next, child signal and get PID API. As we know that the child signal is generated by the kernel to the parent process when its child process was shortly terminating. I mean, say for example, there is a one process named as A is the parent process and B is the child process. If the child process B is terminated shortly, so in that case, the parent process will receive the one signal from the kernel, that is child signal. So now, whenever the child signal is received by the parent, at that time the parent will call the one API, that is going to be the API. So that context, what are the possibilities are there? So that we are checking here. The first one, parent accept the default action of the child signal. So as we know that whenever the signal is received, the one of the action will be taken, that is the default action, encoding the signal, or it might be calling user different function. But as we know that default action is nothing but terminating the process. But in this case, we are not terminating any process. Just what we are doing is here, we are fetching the details of the terminated child process. Yes, is it clear? So we are not terminating the parent process in this context. Just we are fetching the details of the child process here. Ignoring the signal means if suppose currently the parent process is performing some other activities, so in that case just we are ignoring the signal. And third one, child signal. So usually this is happen nothing but we are calling the user different function to handle the signal here. So next one, SIG set jump and SIG long jump API. I think already we know that set jump and long jump. The purpose of go to label is whenever you want to the function. Something is went wrong, so I can use the go to label to transfer the control. But if suppose there is an something is went wrong in other function, I mean outside the function. Say for example, as I'm using the main function, under that main function as I'm calling the add function here, as part of the add function there is something went wrong. I want to transfer the control back to the main function. So it is not possible by using the go to statement. So in that case I need to go use the set jump and log jump. Already we discussed. Similar to that, we are using the signal set jump and signal log jump here. So just we can go through the two APIs here. Signal set jump and log jump is having the two arguments. One additional argument is save signal mask. Nothing but it will preserve the signal mask value. What happens usually whenever we are transferring the control from one function to another function, in that case, whatever the values we stored in the signal mask related to the signal, that will be clear automatically. So to preserve the signal mask value forever, so I need to use the signal set jump API, signal long API. Related to this, we can find the 2 points here. The signal set jump and signal long jump are created to support the signal mask processing. Specifically, it is implementation dependent on whether a process signal mask is saved and restored when it invokes the set jump and long jump API respectively. The set jump API behaves similar to set jump API, except that it has a second argument, as I already told, save sigmas. Nothing but allows the user to specify whether the calling process signal mask should be saved to the provided environment argument. The signal long jump API does all the operation as the long jump API, but it also restores the calling process signal mask if the mask was saved in its environment. So what we need to understand is that whenever the control is transferring from, that is set jump or signal set jump to long jump, we'll see that is the one example shortly I will discuss. The read value argument specifies the return value of the corresponding signal jump. API when called by the signal long jump API, its value should be non-zero number. So that is nothing but we need to take other than 0 value here. The signal long jump API usually called for the user-defined signal handling function. This is because process signal mask is modified when signal handler is called, and signal long jump should be called to ensure that the process signal mask is restored properly when jumping out from the signal handling function. This is an example what we are already are taken. It is with respect to simulation API. Only thing is that here signal long jump API we are taking. This is as I told, this value is other than 0. Just we can find it here. To this as we execute this statement. Next here, sig action threshold is executed. Nothing but we are adding the input signal. Then we are calling the sig section API. So first time if we call, it will take the 0 values other than this. So in that case, this statement is not executed. It will execute the export. Return from first time signal section is called. So once pause is executed, then the control is transferred to user defined function. There is nothing but here and this one. So in this case, as we know that this statement when it is executing, the return value should be 2. So once again we are executing the same part, but this time sig action, this statement is executed. So the return value is 2. 2 is not equal to minus 1. That means, so here this statement 2 is not equal to 0. This is a true condition. So return from signal interruption. This statement is executed here. So kill API. So the purpose of using the kill API is that just like we are using as the inter-process communication between the two processes, that to be related process. Nothing but usually it is a parent and child process. The one condition is that sender and receiver process must be related such that either the sender process a real or effective user ID matches that of the recipient process, or the sender has the super user interfaces. For example, the parent and child process can send signal to each other via kill API. So just we can go to the prototype for the kill API here. First argument PID, nothing which process, for which process I wanted to send the signal. Second one, that's what the signal number. So what's the signal you wanted to send here. The return value of this API is 0 on successful conditions, minus 1 on failure. The argument of that is the signal number is nothing to a signal to be taken. And there are some possible values with respect to PID is that PID is greater than 0. The signal is sent to the process whose process ID is PID. Nothing that we are sending, the process, one process is sending to the other process. What kind of a process the destination process is? It is whose process ID is exactly same. Say for example 4 the sending the signal to process which ID is 4. Next second case PID is equal to 0. Signal is sent to all the process whose process group ID is equals to process group ID of the sender. That means both sender and receiver should have same PGID. I think I already used that term. PGID is the name process group ID. In third case, the signal is sent to all the processes whose process group ID is equal to absolute value of the PID and for which sender has the permission to send the signal. That is nothing but absolute value means it is a technical. If suppose there is a negative value -4, then it will be taken as a +4. So we are sending the signal to all the process whose process group ID equals to absolute value. That's important. And next PID is equal to 0. Then we are sending the signal to the kill signal to all the processes to the system where the sender has the permission to send the signal. Means only that means suppose what happens sometime there is a fourth process, the sender is having the browser for only can send the signal to A, B only, it can't send the signal to C. So in that case the fourth case is executed. This is the simple example what we can see that as per this program we are requiring 3 arguments. So here by using scanner switch statement we are fetching the details from the command line arguments. So according to that we are sending the first example here kill, nothing but the command signal number and PID. So this way we are executing the program. So alarm API, as the name indicates, alarm API is usually used to generate the alarm signal after certain number of clock seconds. So this is actually having the view on already, there is a time input. Let's say for example if I am given the 30 seconds, then after 30 seconds the alarm signal will be. So what we need to understand here is that the purpose of using alarm API is that to generate the alarm signal after certain interval of the time. So this is a simple example with respect to the alarm API. In this case, in this example, we are sending the alarm signal. It is an implementation of sleep API by using the alarm API here. So what we need to understand in this program is nothing but so as we know that sleep is nothing but a particular process enters the sleep for a certain amount of the time. Nothing but say for example 10 seconds. During that 10 seconds, the process is not doing any work. So after 10 seconds only, so it can send the signal. Okay. So this is about with respect to the alarm API. Just like the alarm API, the interval timers. Interval timer is nothing but we are giving the certain amount out of the time. So in that time only, the process should complete a task. Okay. So that is also implementing by using the alarm API here. So we continue some more concept in the next video.